Targeting tax objective number 5. The student will demonstrate an understanding of quadratic and other nonlinear functions. Which of these 4 functions produces the widest graph? In order to answer the question in number 1, we need to get our calculators out and graph these equations. Let's go to y equals and place all these equations in y equals. So in y1 we want to place negative 2x squared. In y2 we want to place 5x squared. In y3 we want to place negative 1/2 x squared. And in y4 we want to place 1/4 x squared. To make sure that our graph's in a standard window, go to Zoom 6. The graphs will be placed in the order that you input them into your calculator. You can see that the widest one is this graph right here. In order to make sure of the equation for this graph, we want to go to Trace. The cursor, as you see, is at the point 0, 0. Since all of the equations go through the point 0, 0, we want to move the cursor off of that point so we can determine which graph we're looking at. The equation for this graph is given in the top left corner of the calculator. You can see that this graph is not the widest graph, so in order to get to the widest graph, we need to use our down arrow key and go to the graph that's the widest. Now the cursor is on the widest graph, and you can see that the equation for this graph is 1/4 x squared. So our answer here is choice D. 1/4 x squared would be the widest of these graphs. Problem number 2 asks, what is the effect on the graph of the equation y equals 3x squared when the equation is changed to y equals negative 1/2 x squared? Again, what we want to do here is to place both of these equations into y equals. So go to y equals and clear out anything that is there. In y1, we want to place the equation 3x squared. And in y2, we want to place the equation negative 1/2 x squared and compare these graphs. The first graph is y equals 3x squared. The second graph is y equals negative 1/2 x squared. Since there are only 2 equations here, it's easy to remember which is which. So we're going to just label these on the calculator. Now let's read our answer choices. In F, it says the graph is wider and reflects across the y-axis. In each one of these answer choices, the graph that they are talking about is this one. So this graph is wider, however, it does not reflect across the y-axis. So this is not a good answer. G says the graph is wider and reflects across the x-axis. That seems like a reasonable answer. So let's mark this one to come back to. Choice H says the graph is narrower and reflects across the y-axis. It's not narrower, therefore this would not be a good answer. J says the graph is narrower and reflects across the x-axis. Here again, the graph of y equals negative 1/2 x squared is not narrower than y equals 3x squared. So J would not be a good answer, And the correct answer here would be G. Number 3. When graphed, which function would represent f of x equals x squared plus 5 translated down 7 units? On the TAKS test, you are often given a grid for a problem, or there is also a piece of graph paper located at the back of the test. However, for this problem, we're going to use our calculator so that we are less likely to make a mistake. So let's go to y equals on our calculator and type in x squared plus 5 into y1. And into y2, let's type in the same equation, x squared plus 5. But to translate it down 7 units, let's subtract 7. Now graph. There is y equals x squared plus 5, and then translated down 7 units, the same graph. Notice that the second graph was translated down 2 units from the origin. Let's go and look at our equations again. And when we look at our second equation, we notice that if we combine the plus 5 and the negative 7, what we get here is x squared minus 2. Therefore, the correct answer here would be C. G of x equals x squared minus 2. Number 4. Which ordered pair represents one solution of f of x equals 0 when f of x equals 3x squared plus 5x minus 2? F of x equals 0 means the same as y equals 0, which is the same as x-intercepts and is the same as zeros or roots. All of these represent the solutions to a quadratic equation. We're going to solve this quadratic equation on the calculator. So let's go to y equals and put this quadratic equation into y1. 3x squared plus 5x minus 2. Again, a standard window, zoom 6, and it will graph it. The solutions, again, are located at the x-intercepts. So we want to calculate a 0 in the calculate menu. Number 2. So the calculator is asking us for a left pound, so we want to move the cursor to the left of one of those x-intercepts. Press enter. Then move the calculator cursor to the right of that intercept and press enter. Now move the cursor to where you want it to guess and press enter. We find here that one of the zeros or solutions is -2, 0. Now let's find the second solution. So we go to 0 on the calculate menu and move the cursor to the left of the other x-intercept. Then move the cursor to the right, and now have the calculator guess what that would be. Here it tells us that our 0 is at 0.33333, and you need to recognize that that 3 repeating is the fraction 1/3. So the solutions to this quadratic are -2, 0 and 1/3, 0. So when we look at our answer choices, the answer that's there is choice H, which is 1/3, 0. Number 5. The path of a ball that is thrown upwards can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. How much time elapses while the ball is 50 meters or more above the ground. Our equation here is h equals 35t minus 5t squared. The problem asks us about the time when the ball is at 50 meters, so we need to substitute in 50 for h. On earlier objectives, we treated an equation like this one as a system. So let's go to our calculator, and in y1 we want to type in 50. And in y2, the other side of the equation, and we have to replace the t with an x, so it's 35x minus 5x squared. Let's look at a standard window for this graph. And notice here that we cannot see the entire graph, nor can we see the line y equals 50. So we're going to have to go to Window and adjust this. Since y1 equals 50, we need to at least double that, so the y max should be at 100. Now graph. There's y equals 50, and here's the graph of 35x minus 5x squared. The problem asks us to find how much time elapses while the ball is 50 meters or more above the ground. So we need to calculate these 2 points of intersection to determine their times, so we can determine how much time has elapsed between those points. So let's go to second calculate, and we want to calculate the points of intersection, so choose number 5. The first curve is our line y equals 50, press enter. The second curve is the quadratic, press enter. Then move the cursor close to one of the points of intersection and press enter. Notice that this point of intersection is the point 2, 50. Now let's calculate the other point of intersection. So go second calculate, again intersection number 5. The first curve is the line. The second curve is the quadratic. Then move the cursor closer to the point of intersection and press enter. That point is the point 550. In the points that you see, the x values represent time. So to figure out how much time elapses while the ball is 50 meters or more, we need to subtract those times, so that 5 minus 2 gives us 3. Therefore, 3 seconds elapses while the ball is 50 meters or more above the ground. In problem number 6, Avery competed in an archery contest. She shot her arrow at a target in a path described by the equation y equals -4 plus 17x minus 5x squared, where y is the height in meters and x is the time in seconds. When will her arrow be 10 meters high? Again, our equation here is y equals -4 plus 17x minus 5x squared. Y represents the height, so we want to replace the y with 10. We, again, are going to take this equation and put it into our calculator as a system. In y1, we want to put the value of 10, and in y2, we want to put -4 plus 17x minus 5x squared. We want to start in a standard window. There's the line y equals 10 and the quadratic. Since we cannot see the top of this graph very well, we need to go and adjust our y max again. Since the value is 10, we need to double that and make it 20. As shown by the graph, the arrow is going up and it hits a height of 10 meters on its way up, and then as it's coming down it hits a height of 10 meters. So you can see that there are two answers. We need to calculate the intersection of these two curves in order to find the answers. So let's calculate intersection number 5. The first curve is the line y equals 10. The second curve is the quadratic. And move your cursor closer to one of the points of intersection and guess. So you can see here that one of the points of intersection is the point 1.410. Now let's calculate the other point of intersection. Again, number 5. The first curve is the line, and the second curve is the quadratic. Then move your cursor closest to that point of intersection. So here we have the point 210. What these points tell us is that the arrow will be at 10 meters at 1.4 seconds, and the arrow will be at 10 meters at 2 seconds. One is going up, the other is going down. When I look at our answer choices here, the only answer that appears here is G, 1.4 seconds. Therefore, G would be our correct answer. For objective number 5, the calculator skills that were targeted were graphing and comparing the graphs. In problems number 1, 2, and 3, we graphed the equations that were given and compared the graphs in order to answer the questions. In problem number 4, we calculated zeros, or roots. Remember that zeros, roots, x-intercepts, and solutions all mean the same thing for a quadratic. In problems 5 and 6, we calculated points of intersection in order to answer the questions. We looked at the window. Since the graph was not visible, we had to adjust our window in order to see the entire graph. This concludes Targeting TAKS objective number 5. The student will demonstrate an understanding of quadratic and other nonlinear functions.